Welcome back to grade 12 mathematics. Today we're going to deal with unit 2 algebra. So under unit 2 we're going to discuss expressions, equations, inequalities and roots. So for example, x plus 1 is an expression. X plus 1 equals to 0. It becomes a equation. Then an inequality is x plus 1 is greater than 0. Then it becomes an inequality. Then roots, we are talking of, for example, if we've got a graph, this is the y-axis and this is the x-axis, and the roots is where they meet on the x-axis. So in this case, it's a quadratic equation with two roots here and here. So let's look into this example. So you can solve it graphically, right? Or through solving an equation, solving this equation. So in solving, you solve, interpret, and check. So let's do this one. X plus minus 5x plus 6 is equals to 0. So in order to solve this, you look at the product of the coefficients of this one and this one. So here, remember, there is a 1. So it becomes 6. So that product is 6, but when you add them, they should give you 5. So we know that the only way we can do that is to get a product. It will be minus 3 times minus 2. It becomes 6, but when you add them, you still get minus 5. So then this, you separate the middle one, so it becomes x squared minus 3x minus 2x plus 6 is equals to 0, right? Then you factorize x, it becomes x minus 3. Then here you factorize minus 2, then it becomes x minus 3 is equals to 0, right? Let me delete this so that I have space. Then we solve now. Then it becomes x minus 2 x minus 3 is equals to 0. Then you simplify. Then it becomes x is equals to 2 or 3. So these 2 and 3 are the roots of this quadratic equation. So this is what we're going to deal with in this unit. So let's move on. Unit roadmap. What learners should be able to do by the end of this algebra unit. Number 1, they should be able to manipulate expressions like terms, brackets, fractions. Then you should be able to factorize strategically, find common factors, squares, and trinomials. Then you can also solve quadratic equations. So you can do it factorization, completing the square using the formula. We're also going to deal with interpreting roots. So discriminate and graph character. Then we're going to solve inequalities. Then we find critical values and intervals. Then we're going to do solve simultaneous equations, intersection points. So this is actually under paper 1 foundation. So algebraic fluency supports functions, calculus, finance, and probability. So this is a foundational unit which fits or which is applied in several concepts like what I've mentioned here: functions, calculus, finance, and probability. So let's move on. Expressions versus equations. So for this section, in order for you to minimize errors, so the first distinction that prevents most algebra errors is to know what's an expression versus an equation. So an expression, as you can see on this left side, is a mathematical phrase, and it can be simplified, expanded, or factorized, but not solved because it's not an equation. You can see there's no equal sign. So the first one is x plus 7. The other one is 3a squared minus 5a plus 2 is an expression. Then the other one is a more like a fraction where the denominator is x plus 3 and the numerator is x, 2x minus 1. So this one is an expression. So an expression is where there's no equal sign. You can see there's no equal sign. So on the other side, on the right, you can see an equation is a mathematical statement with an equal sign. It can be solved because it claims two quantities are equal. For example, you can solve 3x plus 5 is equals to 17. You can say 3x, take 5 to the other side, then it becomes 17 minus 5. Then 3x is equals to 12. Then x divided by 3 both sides is equals to 4. So you can solve it, right? So this is an example. So solve only when equality is stated. So equality is stated by an equal sign. So next one, like terms and operations. So only structurally identical terms may be added or subtracted. In other words, for example, same variable part and same powers. So let's give an example. So you can see there is 3x and 5x and 8x. So 3x plus 8x is equals to 11x. So they've got what? They all are under x, so they can be added. But if it was 3x plus 8x squared, it cannot be simplified further because this one is x squared, this one is x. So they are not structurally identical, as you can see here. But as you can see, for the other ones, you can see it's minus 5a. You can add it, for example. Then it becomes 6a. Or you can subtract it, like, I remember it's a squared here, sorry for that. You can subtract it as well. Minus 5a, then it becomes minus 16a squared. So in other words, you can add, they can be added or subtracted, right? So unlike terms, I've already covered it, as you can see here, and here, and here. These ones, they cannot be added or subtracted because they are not sharing the same terms, as you can see. So example, so if you are asked, maybe let's say simplify this one, so you can identify that these ones are sharing the same term, so you can group them together, and 7x and 4x you can group them together. So you take these two, then you take these two. So that's how we get here. Then you further simplify. So 6x squared minus 2x squared is equals to 4. Then 4x plus 7x is equals to 11. So this is how we... So remember, like terms and operations, only structurally identical terms may be added or subtracted. So when you identify those, then you are able to solve and or simplify. Next one, expand in brackets. So when you expand in bracket, you distribute, its distributive multiplication must reach every term. When you say distributive multiplication must reach every term, for example, the expression here, it's similar to saying x, a, b plus c is similar to say a times b plus a times c, which is equals to a, b plus a, c. So that's what we mean by saying distributive multiplication must reach every term. So in other words, you cannot end here at a times b, then you end, but you must also multiply the a with the c. So this is what we call distributive multiplication. So single bracket, so an example of single bracket. So you can say the term outside the bracket multiplies every term inside. So in this case, we are saying 5x, 2x in bracket minus 3. So it's equals to 5. Remember, distributive multiplication times 2x plus 5x times minus 3. So when you simplify, it becomes 10x squared minus 15x. Right. So I'm using this multiplication so that you know. But normally, when you are used to it, you just do it in your head. To say 5 times 2x is 10x squared. 5x times minus 3